of these 3 points on the graph. So looks like you might have been assigned the first point.
Yeah.
Okay.
Um,
On the graph, plot and label only your assigned point. So that one right there, that's A. So it's good to do the following. It's good to label it with a letter. It's even better to label it with the ordered coordinates there. Any questions on that?
no.
Okay, now part 2 says use a ruler to line up your point with the origin 0, 0. So there's the origin 0, 0. Now, I'm guessing you didn't use a ruler. This is a little curvature to it. We can do a little better here. It's good to have a ruler when you're graphing. Really, really makes a lot of difference. So let's see here. See if I can get a straight line there. Boom, like that. All right. So you definitely want to maybe erase, maybe just sketch in this new line. And that will adjust the table quite a bit here. I mean, not a ton, but it'll maybe adjust it a little too.
Yeah.
0.83, 1 point. Actually, your numbers are okay. I mean, I don't think they're actually what's interesting, like you see how you have 5, 2 in maybe that's why it worked. Okay. So like when I look at a point like this on your graph there, like that's correct, but yours actually goes through 2.54, somewhere in there. But you were keeping this ratio intact, except it looks like the ratio should be y over x. Is that what I'm seeing there at the top? It's a little grainy.
Yeah.
Is it y over x?
Yeah.
Okay. So that's where we're running into some problems here because your ratios definitely don't match up to that. So let's take another look here. Well, some of them do, I should say. Um, no, actually, yours are fine. I guess that's what you were trying to keep intact. I guess that's what I was trying to say. Is it looks like even though your graph didn't match up with this, you were trying to maintain this 0.4 ratio each time, and you did. So I guess they're okay. And then your equation is fine as well there at the bottom. So you actually did this correct. I mean, other than like I'd like to see a little better graph, but you're okay on there.
Okay.
So what questions do you have? Or maybe we should do it for a different point, point B maybe, or I don't know, I can make one up as well. Like what do you think would be best to help you?
Oh, we could do point B.
Okay, let's do point B. We'll do the same thing here. So let me refresh here. I don't know if you have like different color pens or pencils. That's sometimes a
Yeah.
good thing to do. I'm going to switch to blue. So the ordered pair is 4, 5 right there. Oh, why is it doing that? 4, 5. And then I'll grab a line here. Got the advantage of some technology here. There's our line. It doesn't really snap right there. Okay. So now let's make a little table. Let's go X, Y, and then we'll do the ratio of Y over X. Okay, so when X is 1, well, we'll start at the origin. 0, 0, that's undefined. At 1, what would you estimate that Y value to be?
4.
1.4?
Yeah.
Okay. And how about here at 2? What would you estimate the Y value to be?
Um, 2, 2.2.
So 2.2 to me would be closer to this line down here. To me, the point is closer to the 3 line.
Mm,
Like it's not quite in the middle, it's slightly above the middle, kind of where I'm looking at it.
2.7.
Okay, 2.7. There's not a wrong answer here. There's just hey, try it out and see what you get. Now 3, what's the Y value there?
Uh, 3.9.
Okay. And then 4, we know that it is 5. Okay, now let's do the ratio of y divided by x. So 1.4, and you really should show your work here. Did you have a calculator when you're doing this in class?
Yeah.
Okay, now if you're allowed to use a calculator, why don't you grab a calculator and see what you come up with, if you need it. And let's do the same thing for the next one here.
1.4 and 1.35.
Okay. Now let's do the last one here. 3.9 over 3 and 5 over 4.
One 1.3 and 1.25.
Okay. Now, one of the things that I'm noticing here, because I didn't, and look, this line isn't quite on the origin, which is the reason we're kind of off a tiny bit here, which is mostly my fault. But you see the numbers are kind of trending towards this 1.25.
Yeah.
Okay, so if we were to actually do the correct line, and let me see if I can do this. Let me see if I can do it better this time. We'll go up a couple of more places on the line here. You're potentially going to see something here. Let me see if I get this right. Yeah, so it goes to go through there. And somewhere like that. All right. Sorry, this tool doesn't snap very well, but that's okay. Let's go to a point like 6. What's the y value there?
For 6, you said?
Yeah, yeah, for 6.
6.5.
The y value here. Like imagine going across, hitting the y-axis.
Oh,
Like between 7 and 8, where would you estimate it to be?
um, I don't know.
Well, I mean, are you able to see my screen?
Yeah.
Okay, well, where do you see this line between 7 and 8? Like where is it in the middle? Is it towards 7? Is it towards
In
8?
the
Like,
middle.
okay, so what is the number that is in the middle of 7 and 8?
7.5.
Okay, 7.5. Notice I'm not making a big deal about what your estimate is. I just want you to make that decision.
Yeah.
That's important here. So now take 7.5 and divide it by 6.
1.25.
1.25. Okay, so the idea here is that the more points that you graph and you estimate this y over x, they should all sort of trend towards the same number. And this number is called the slope. Did you guys talk about that in class?
Like a brief explanation.
Okay. So the equation of the line is y equals mx, and m is called the slope. All right. Okay, why don't we go to the next page and work on some of those. We've got about 5 more minutes left in our lesson today, so we'll get some of these questions done and see if we can come up with some more, get some more answers here. All right, so this one. All right, so this one is buying something at the supermarket. A lot of people at the supermarket this weekend. If you went out, Costco was very busy.
Yeah.
All right, so it says at the supermarket, you fill your own honey bear container. Okay, customer buys 12 ounces of honey for $5.40. So what you're trying to decide here is which is the input and which is the output. And the input is either ounces of honey or it's dollars. And the output is either ounces of honey or dollars. And the idea is like you're supposed to draw on your experience from real life to know like, does the thing you buy produce the cost or how much you pay, or does the money you pay cause the amount of ounces you can buy? And I suppose you could actually argue it either way, but maybe one of these is intuitive to you. Um, the input goes down here and the output goes here. Do you remember, can you think of if you went shopping yesterday, did you start with money or did you start with what you wanted to buy?
Started with what I wanted to buy.
Right. So the input down here is the ounces of honey. That's the input, which is the X variable. The output is the money, which is the Y variable. Okay, so we know that 12 ounces of honey, so we can maybe make some increments here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6. So we can label this ordered pair 12, comma 5.40. Okay, so and really you should have a grid, you should use a ruler. We don't have any of that. Let me just double check. 1, 2, 3. I need one more. All right. So there's 12, 540 right there. So that's 6, that's 5, 4, 3, 2, and 1. And then 2, 4, 6. And so you want to label your graph when you're working on these things. Don't expect your instructor to know what you're talking about here. So if we don't buy any honey, how much do we pay?
Nothing.
Nothing. So that's always an ordered pair here, 0, 0. And then we're going to connect the two lines here, 2 points with a line right there. Got it. Okay. So you want to have something like this down on your graph. As you remember, I will send you the note after we're done, so you can do that. But the idea here is that you can do the same thing we did in the previous problem, which is create a little chart, with X, Y, and then Y over X here. So we know at 0, it costs 0. Let's say you wanted to buy like 4 ounces of honey. How much does that cost?
Um,
Roughly. I mean, doesn't have to be exact.
$2.
$2, that's fine with me. How about 6 ounces of honey?
$3.
Okay. And so you can keep doing this and you get up to 12. We know that 12 ounces of honey costs $5.40. This is we're going to do these ratios of Y over X. So it's 2 over 4, which is 0.5, 3 over 6, which is 0.5. But the one that we really want is the one with the given point. That's going to give you the slope. So can you go to your calculator and do 5.4 over 12?
Yeah. 0.45.
0.45, good. So that is the slope. The slope is 0.45. And so we can answer this first question here real quick here. It says, how much does honey cost per ounce? Well, it is the slope. The slope is the answer to this question. because the slope tells you the y units, which is dollars, over the x units, which is ounces. So it's $0.45 per ounce. And last little thought here, question part B is very similar. It says how much honey can you buy per dollar? Well, it's the same answer. Kind of. It's using this answer to determine that. So if you have $1, that's where we go back to the graph here, kind of figure out, well, how much can we buy? Well, if you have $1 here, let me go back to the graph. Green here. If you have $1, you hit the graph, you can see that you can buy sort of somewhere between 1 and 2 ounces, maybe 1.5 ounces. There is a better way to do this, but we just don't have time for that. I do have a lesson here coming up, so we have to stop here for today.